Good afternoon, sir.
Good afternoon, man.
Good afternoon,
Good
sir.
afternoon, sir.
Mm.
Good afternoon, sir.
Good afternoon.
Good afternoon.
Good afternoon. Okay. Uh, Good afternoon, all of you.
Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
It's been after a long break. We have been meeting here.
Good afternoon, sir.
Good afternoon, sir.
So I thank Shanmukh sir for engaging the class all these days. I was a little bit busy. I was out of station all these days when I'm not there in the class. Is my voice audible to you all? Is it clear?
Yes, sir.
Yes, sir, it's clear.
Yes, sir.
Yes, sir.
Okay. So what is that we have discussed in the last class, maybe on Friday? Can anybody just remind me of what we have discussed in the last class?
Binary elements.
Okay. Have we discussed the solution of,
Functions. Yeah, some functions we're discussing.
yeah, a solution for the binary has been discussed? Hello?
Sir, you said about arrays also, sir.
Okay. So I was talking about arrays also. Okay. So I think we have finished arrays, and I even asked the people to put that zeros and ones in the arrays and start to calculate. So have we discussed about that solution?
Yeah, sir, we have discussed.
Okay, we have discussed it. So I think all of you are good at that one. Um, okay, right. So I think we also have discussed about functions, right? The return values and everything.
Sir, we did not discuss return values, sir.
We did not discuss return values.
Oh,
Okay,
return.
right. So we only discussed about functions. I
Yeah, so
think
some f of I, some n, that thing we discussed, sir.
I think we have discussed about return values also. I think, right? That output, input, we have discussed it, right?
No, sir.
I will just show you. I think you will remember it. Uh,
Maybe we forgot the name.
Yes, actually, we discussed it like while we are creating a function, we should have one input value and one output value. Have you remembered it? So we are sending two ways like addition. We want A, comma B, comma output. So we are getting the output here. That's what the return value, right? Have you remembered that?
Sir, are you sharing any screen, sir?
No, no. I am just opening the Raptor now. At present, I am not sharing. Okay, now I will share. Okay. So I think while we are creating a function, we have been doing this. Okay. So for creating a function, I said we need to add procedure, right? So this add procedure, I told you that I am using this add function. Okay, add, and I told you that one parameter will be uh, number one as input, and the other parameter will be number two as input, and the last one I'm checking it as output. Okay, so I'm giving it as out. Right, this is what the function will be prepared with. So two inputs and one output will be there. That's what I have discussed earlier. Right, it has been created. The next thing I will do is I will give it something like, because our out is the output, so I will simply give out is equal to num1 plus num2. This is what the formula. So this is for addition. In general programming, what we will do is we don't mention any output or the return value in the function itself. But instead, we only give two parameters or three or n number of parameters which should be taken as inputs. Okay. So here it is not like that, but in programming we give only number one and number two into the function, and after getting something like out is equal to num1 plus num2, we just return the value, return out. That's all. That's why I call it as return value. But here there is no keyword called return, and there is no aspect of returning something. So for that, what I will do is that beforehand, I will mention what is the value that I need to be returning it. So what is the output? So the output will be this. So whatever value that comes here when adding num1 plus num2 will be sent to out. So now out is having a memory in the RAM, right? And coming to main, whenever you call this function, so whenever you call this function, what you need to do is you need to mention something like the function name add the two numbers num1 and num2 which we are sending, right? 2 comma 3. Directly I'm sending the numbers itself. I'm not storing them in any variable and sending them, but I'm sending them through a direct contact. Okay. And now I will write something like out here. I can write any name, as I have already explained how the functions will work. I have even explained you earlier using Mario example, and also some two people example going from India to America having different rooms, something like that, right? So the same way you can write output or answer anything, whatever that is there in the out variable of that function like add will be coming and replacing with this particular out or answer or whatever A to Z, any variable you can use that will be just replaced to it. I just draw one thing on the board so that you will get it. Yes, I'm okay. I need to save it. Okay. So this is what I have done, right? So I will just show you how it actually works inside it, right? So if you consider this one, I have created a small one called start, right? Okay. And then a small call function, which I have just created it. Okay. And here I have written something like add of 2 comma 3 comma out. Okay. And then I have just stopped it. And in another case, I have just wrote a function which is start. Because it's a function, it is receiving some parameters. I have written like it is returning number 1, number 2, and out is the output. For that, it clearly mentioned this is in input, this is output. Okay. And the next thing it does is I'm just assigning some value to out. Out is equal to num1 plus num2. And immediately after that, I'm just stopping this function. Now this is, I say main, and this is a normal function. Okay, this is where the control starts, and it goes here from this, it goes here step by step, stop, come back, and then to the next step. So this is 1, this is 2, this is 3, 4, 5, this is 6, and this is 7, the last one. So this also I name it as 7. So this is how the steps will be gone through the functions generally. And now you might be need to have a clarification like what is this out? Okay, put it red. What is this out and this out? Okay, let us see what will happen. Okay, so if you take separately the main and the function, so what happens is when you say something like n1 is equal to 2, n2 is equal to 3, out. We don't know what is out, right? But why I'm mentioning out is because I am taking it as a memory. So if we have done like this, what happens is there is an address that will be created maybe for n1. Have you remembered that in arrays we are discussing about indexes, right?
Sir, yes, sir.
Yes. So like that, each index will be created. We don't know what is that stored in that. So for this, I will just show you how indexes will be created. So we will have something like this. So we will have n1. So maybe some address 2101 it is stored. So the address here is 2101. And n2, because they are not array, they can be placed randomly. So maybe 4010. This is also 4010. And out is there, right? Out's address is 1100. Okay, this is also 1100. This is randomly placed. The same thing I have done for the function, right? For the function also I have given num1, num2. So I will say, so if you imagine that I have declared, see in the earlier flow chart I have just given 2 comma 3, but here now I am simply declaring it with a variable. n1 is equal to n2 is equal to 3. So what I will give in our flow chart? So here I will say n1 comma n2 comma out. Okay, and in that case I am telling this example. So here num1 is equal to, we don't know still yet, until unless we are sending the values we don't know. Now we will go through the flowchart and see. Okay, slowly we will change the values like that. Okay, I will create a small memory for it. Okay, so I will first write down all. So the next thing is num2. We don't know what is this still. Okay, and the last one will be out in the function. You see I have written out here and also out here. So these two outs are different because this is separate world and this is separate world, and their functions and their variables are also stored separately, right? And now the next thing will be, I will draw the index. Now this index is for the compiler's reference. So I will give some address 16105. So I told you already the addresses can be expandable to the and it depends on how many bits it can store. So for example, if I am saying an integer can be stored with 64 bits, okay, that much highest number is there. So the address will start from 0 to that much highest number. So for example, if you go to 32 bit, the maximum number that you can store is something like 400 crore change. So address will also start with 0 and end at 400 crore change. Any number can be your address. So whatever the computer can generate, that can be your address. So here and num2 maybe 65,000. There should be no commas. 535, and the last one will be out, and here maybe 2610. So have you seen that here the out is 1100 and here the out is 2610? That means this out is different from this out, and they can be named in different values. And now I will tell you how actually Raptor works when I come to the operational mode. Generally in programming, until unless we use the return keyword, the value will not be returned to the main. But here, because it's a flowchart, the return keyword has been taken away from it. and it was returning because the out, whatever that comes in the place of out, will be simply copied here. Now let us see. Coming to our operational mode, I'll just try to make something that is clearly understandable by you. So I will give N1, 2, like whatever I have done, right? And I will give N2, 3. Okay. So here I will change it something like N1 and N2. Okay. This is what I have done. Now coming to N1 and N2, we have given 2 and 3. Yes. So this memory will be filled with, so whatever you said, something like these are the statements like N1 is equal to 2. Now, because you have created N1, now the computer will check what is the address. Okay, 2101. So now it will slowly check where is 2101. And yes, it has found it. So what it will do, it will place 2 in the memory, which is indicated by 2101. Okay, like yesterday I have told you clearly during the array class. So please download those videos because they are being erased for your future reference. Now next I gave N2 is equal to 3. Now it comes to the index. So you say this is index, is also index. And now N2. So it will slowly go search for where is the address. Yes, it has found it. So it will keep 3 as the value. Okay. Now out 1100, but out I think we did not give anything. So until unless out is receiving some value, it will always be null. So null in the sense we can represent like this, or it might be garbage value. At present it should be null. Okay. Now after this, what we have done is, after filling out the memories, now we have sent add of n1 comma n2 comma out. So what happens is, whatever that is there in add, you can just see this is add, which is receiving number 1, number 2, right? And also out. Out anyway it's null, and number 1, number 2 are already filled with 2 and 3. So just we send 2 to num1, 3 to num2, and null to that out here. Okay. So now let's see. So what I will do is, because I am calling something like function, maybe in our case add n1 comma n2 comma out. So because we are actually doing like this, the function is actually receiving, right? Num1, sorry, num2 comma out. Now let's see. This 2 will be sent to num1 because it is parallel, right? This is the first input, and here also this is the first input. So it will be sent here. So what it says, okay, now num1 should be filled with 2. What is num1? It will search here in the index. Okay, so num1 is having this address. Yes, I found it. So I will copy 2 here. Okay, what is the next one that we have? N2. N2 is the second input. What is the parallel input that we have here? Num2. So now what the compiler will do is, I need to put this value to this one. So it will search where is num2. What is the address? Yes, this is the address. I need to search for the address. Yes, I have found here. Of course, these are all randomly, but I am keeping it in a line. But that's why I'm saying that I will search and find it. Okay, now I have this one, so I will keep 3 here. Okay. Now what is the last one? Out. The output belongs to out. That is the third that we are receiving. So it will see that it is null. So this null should be carried out here. So it will find out that this is here. null initially. So I think there is no need for question mark because we already got the values. So we generally need to write them like this. Okay, I filled with 2, next 3, and null. Okay, so what is the next thing that is happening here? The next thing is I am giving out is equal to num1 plus num2. That means some assignment. So now to perform this operation, again the compiler will check what is num1, what is num2. Yes, num1 is here, num2 is in this address. So it will take 2 plus 3 will be assigned to, I gave you clearly that out is equal to num1 plus num2. So the out will be given to 2 plus 3. So 5. What happens is it will now search where is out again. It sees the address here. Okay. So instead of that null, it will replace it with 5. The 5 will get replaced. And I think we already got output. And here one important thing is when the output is filled with some value, the final thing that happens is we get out and end the function. After ending the function, it is coming back here. So that means this out will be filled with the previous value that we got. So this is 5, right? Now it thinks that whatever the output, whether it is answer or out or whatever it might be, there need not be any same names for these. So, but still it thinks that this category is input, this category is input, this category is output, right? So this is very important here. Based on the categories, the values will be transferred to that same category. Okay. Here also we need to talk about this is input, and this is output. So whatever that is received in the previous functions input is transferred here. After doing some functionality here itself, the output that we got will be now sent to the category out, right? What is the category out here? It is, this is the variable. So what happens is it will now get copied into this output. So simply this null will be erased and 5 will be stored in this. And this is how automatically the return function works. The return keyword works actually. So without even writing what is return, we just simply get the value that we got the output. See, once again, I am just telling it in a glance, at a glance. We got n1 and n2 2 comma 3. When we are sending, the values will be copied to their parallels. Okay, num1 and num2. After finishing this assignment 2 plus 3, that means num1 plus num2, the out is filled. What is this outs category? Is output category. So whenever you get some output category that is filled with a value instead of null, it will be immediately transferred to the function that is calling it. So this function is called calling function. This function is called calling function. This function is called called function. Why I'm saying calling function? Because main is calling this function and function is called by main or called by somebody. So when somebody is calling you, you will be said as called person, right? But when you are calling somebody, you are said as calling person. The same thing happens here. Because main function is calling the function here, the sub function. So it is turned as the main will be called as calling function because it is calling. And this is being invoked by main. That's why it is called function. Okay. ఇది పిలుస్తుంది, ఇది పిలవబడుతుంది. In Telugu, what we say. Okay. Okay. Now coming back to our this thing. So whatever that is there in the call, whatever that is filled in the output of the called function will be immediately transferred to the output of the calling function, and this is how the values will be returned. Okay. So have you got clarity on what to do? So now the simple thing is that we output the out that we got. So without any confusion, if I can change it as answer. Whatever you give, that will be received. Okay. I can also do it as answer. You can see it here. And I want to put answer. Okay. Yes. Put answer. So this is add of n1, n2 answer. So null will be going to this out. Here also you can change, though, no problem. And here the out will be getting this one. Whatever that is there in the out here will be transferred to answer. So we got the value from the function. And now we are just printing that answer. So that is how it works. And have you all understood it, what I said?
Yes, sir.
Okay. Right. Is there any doubt here? You can ask me now.
No, sir.
Anybody has any doubt? If somebody is talking, is
No,
somebody
sir.
asking a question?
No doubt, sir. I said no doubt.
Yeah, okay, okay, fine, Rohit. Thank you. So now I want to show you one concept. Until now, we have been calling the function and returning it back. So that's what we are looking into. So until now, a function is calling another function, and whatever that is there in the function is returned back to this function. Okay, this is how it is done. Now, there is some concept where, for example, for factorial, I think we have been doing like using for loop, right? For loop, we are using, sorry, not for, you don't understand for loop, but we are using loop, right? In the
Yes.
loop, what we are doing, we are starting with I is equal to 1, and we are multiplying with 1 into 2 into 3 into 4 up to some n. Okay, whatever n value that is given. So without loops, we can also do it just by calling a function with itself. That means a function calling itself. So it will be both calling function and called function. Okay. So for example, in our previous case, our main function is calling function one or add, for example, add function, and it is returning the value. But what about in the case main function is calling sum of n number or factorial? Let us say factorial. Okay, factorial function, and the factorial function is calling itself to solve the problem, and final value is returned to main. This is quite confusing to all of you. How come a called function calls itself? So have you ever remembered that whenever you are talking to somebody and you feel somewhat unconfident, the most important thing that you do is you will call yourself, okay, Kranti, you can do it, right? Who is Kranti here? Kranti is me. I can call somebody, but what is that I am calling myself? So that means to do some solution, to solve some problem, the only important thing that remains with us is calling ourselves at some point of time. Okay, Kranti, you can do it. Come on, do it. And you can write down this exam very fast. See, I am telling myself. The same thing happens with the functions also. Functions need not be calling other functions, but functions can also call themselves by calling their own name. So I can simply write a function like this. So in our case, I can simply write function, some input, some output, and in the next line, I can call the same function. So this is the start. Okay, this is start. In this, I can call simply my own function name by giving the input and output. So I'm just returning the output for myself. So this is somewhat equal to this one. See, this is a mirror that we see generally in barber shops, right? So while we are sitting, we look into ourselves and it is an infinite thing. If you don't stop somewhere else, it goes on showing yourself. So that means the mirror is reflecting itself with another mirror so that we look all the images like this. So we call this as recursive, right? So it's never stopping until we give a condition. Somewhere we need to stop it. Otherwise, it will be infinite number of images that we are getting here. The same two persons on the mirror is reflecting itself with its own mirror and the same two persons again and again. Okay. So this function is also called recursive function. That means like this recursive mirror, which is showing itself, we call this as recursive function. So this concept that we are entering is recursion. Recursion in the sense a function calling itself until some condition is satisfied. Okay, let us take the example. For example, you have a fact function, right? So I have fact. I'm sending n, comma, answer. And my n is 1. Okay, my n is 1. And here coming to the fact function itself, this is main. And coming to our fact function, this is fact. It is receiving something like a number and output. And the next thing that happens is I just return in the sense that I will just put output is equal to num. Okay, and end it. And if I print here, answer, what will be printed naturally?
1.
1, right? So whatever that is there in the output, because it's 1, there is nothing to write into the factorial. So 1 is the ending for factorial, right? There is no multiplication, nothing. If you give 1, 1 should be returned. That's all. So that is why what I have simply done is, assuming that my number is 1, I will simply give 1 to the output, and whatever that is there in the output is belonging to the category of out. That will be transferred to answer, which also belongs to the category of out. So if you print answer, the answer will be printed as 1. Now, for example, I am calling n will be 2. So I think for 2, it should multiply with 2 into 1. If only 1, I am just sending 1. But if I am just increasing one another number in the factorial, I should be doing 2 into 1. I think I have seen two things here. The things are, first I send 2. Next thing I need to multiply with 1. So I divide them into two things. Let us see. Because it is 2, I write it on paper like 2 into 1. So I divide them into 2, it's separate, 1 separate. I think you can observe that for 1, it's most easy that this is the case. You can simply write fact of 1 comma output. The next line will be output is equal to the whatever that 1 that comes 1 and ending. Fine. This will return 1 anyway. But we should multiply these two things. What about this one? So if you write it like fact of
Num into
output, I think we cannot directly send output is equal to 2, right? We cannot directly send output is equal to 2, but because if I give n is equal to 3, what happens? We cannot directly return 3 as the output. Or if you get 2, okay, you will write 2 into 1. But what happens if it is 2 into 1, 1 into 2 into 3? So I think everywhere, if you consider this, the number should be returned everywhere. The number should be returned everywhere. Let us write it as this. So what I will do is, if n is equal to 2, let us say what will happen. 2 into 1. So now what I will do is, I will write like this, fact of n comma output. And simply I will give output is equal to n and it. Okay. For this also I will call fact of n comma output. The output here is n. That is 1. Here it is receiving 2, it is receiving 1, and we are ending it. Okay. So here the output is 2, here the output is 1. We are just multiplying it. So, so can we write like this? Maybe fact of 2 comma output into fact of 1 comma output. Can we write like this?
Yes, sir.
Yes, we can write. So
sir.
simply converting this one, I can also write like this. Fact of to become universal, n comma output into fact, sorry, into fact of
N comma
n minus 1,
output.
n minus 1 comma
Out.
output. Right? This can also be written, right? Because if n is 2, it is n minus 1, 1. It is fine. It is working for 2 into 1. But what happens for n is equal to 3? So if you consider the same thing like 3 into 2 into 1. So if you do the same thing like this, the same code for 3, 2, 1, we have finally settled for this, right? Even though you do it, you cannot do it for everything. You cannot count it, right? N minus 1, n minus 2 like that. Okay, we take this formula. Every time we do it like this, fact of n comma out into fact of n minus 1 comma out. So I'm just categorizing each and everything, solving step by step how I can achieve recursion. So if you take this n as 3, because n is equal to 3, what is n minus 1? Only 2.
2.
But what about 1?
1.
There is this 1. Now 1 will become orphan. It will cry like anything. You left over me. Okay. If you give n is equal to 4, if you use the same formula, it will be 4 and it
2
will be
will be
what,
left.
2 and 1. So here it is not working properly. So what I am thinking is that because that is not working properly, why can't I say something like every time n into fact of n minus 1 comma output. Okay, I will give it like output is equal to this one. What happens here? Now just check out. If this is kept into fact of n comma out, because it's calling itself, you see, it's calling itself. So the n is initially 3. What is fact of n minus 1? If n is 3, what is n minus 1 here?
2.
2 comma out, right?
Mm.
So if again I am calling it, the same formula works, right? So 3 into what is fact of 2 comma outputs? Follow the same code.
Uh,
It will
2
be again,
into
yes, it will be again n into
fact of n minus
fact of n minus 1 comma out.
mm.
Replace n because this is calling with n is equal to 2. I will say 2 into fact of 1
1.
comma out. Anyway, 1 we got it, right?
Mm.
Because we got 1, we just return 1. There is no other context like there is no n minus 1 for 1, right? So
Mm.
there is no multiplication. So I think we have two conditions here. If your n is 1, you just return 1 directly without any multiplication. If n is greater than 1, you just do it like that n into fact of n minus 1 comma out, whatever that receives here.
Mm.
Okay, so this is how you get 3 into 2 into 1, and finally this answer will be sent to out, and this out will be given to main, which is calling your factorial. Okay, so now the scenario is like this. You call something like I want fact of 3. Something should be done in the recursion way without any looping. It should return you the value as output 6, and it should be printed. So this is what our scenario is. Okay, now let us try. In programming, it will be very easy for you to do, but here we need to have a little bit of workout because the flowcharts are a little bit different. But if you understand the difficultiness in flowchart, you will definitely understand the recursion in programming. It's very easy. So the same thing which I have written here, I will just write down in terms of factorial. Okay, let us write each step. Okay, right. Now what I will do is I will just send a number. Okay, if you want a little bit zoom, I will do it. Okay. Now this number n is equal to some 3. Okay, num n will be 3. Now I will create a function. Okay, I will create a function procedure. This function name is fact. Will be 1. Sorry. This will be n. That's all. It's also receiving n or num, whatever it might be. The next one will be out.
N minus.
So it's not n minus 1. The fact should be having both number and the output, right?
Yes.
Yes, it is out. Okay, right. So our function has been created already. Our function has been created. Now the next thing that I will do is I will call this function. The function should be called like this. So I'll give fact of, see, it's already giving me how to write the syntax. So I will say n. I am receiving n, right? So n comma my answer. So I will write fact answer. So whatever that is there in the out of that function will be received by fact answer. And finally, I am trying to print this fact answer. Sorry. I am trying to print this fact answer. So whatever I get, I send it, I receive it. So this is only known to main. So now it's our turn to create factorial function. So for that, what I have said, I have two conditions, right? If n is equal to 1, just write down the receiving is only 1. If n is greater than 1, then I need to have this formula, right? N into calling itself, so that all the previous values will be replaced and the multiplication will be sent. Let us see now what will happen. Okay. Now, what should I do for the first thing? Based on this explanation, what is the first line I have to keep in the function? Can anybody guess?
Repeat again, sir.
Assign fact.
Sir, keep selection, sir. Selection.
Selection in the sense, is it like condition that you want?
Yeah, sir. N should be greater than 1.
Yes.
That.
I will keep selection and I will say if n is equal to 1. Okay. It's okay. Anyway, that's enough. If n is equal to 1, then I will assign the out. Out is my output, right? So out will be n. So if it is 1, okay, directly the out will be n. So the out will be returned to answer, fact answer, and the fact answer will be produced. So finally 1 will be produced as the output. But if n is not equal to 1, it should be going to no. Here, it's your
Assign the
turn
formula.
to find out how you give the logic so that the factorial will call itself. So can anybody guess it?
Assigning the formula.
So okay, we will do it. Maybe we shall do it like this. Out is equal to out is equal to n into of n minus 1 comma out.
Hmm.
Okay, let us see what will happen. What it says,
Function is not defined.
the function fact is not defined.
We have to define it.
We have already defined it. We have already defined it. Okay, right.
Once num minus 1, sir.
One
Num
minute.
minus 1.
What I will do is the output, whatever output we get, that output will be given to this out is equal to out into that n. Okay, 1 minute. I will just try out the other way. Just try out the other way. Maybe it is not accepting like that. Oh, the problem is for calling the function, we have another this thing, right? There is no assigning. So in programming, we can do like this. In flowchart, we cannot do like this. So what I will do is simply, I will just decompose that. How I do it. Now, did you understand what is the mistake? The mistake is like this. For calling a function, we have a symbol like this, right?
Hmm.
And we are using that function in the assignment mode. It's not calling mode. So what happens is now that because we are directly using the function here itself, it is saying that this function is not defined actually. Okay, because the function should only be called using this symbol, not this symbol. So in programming, we can write it like this: fact of n minus 1 something, we can write like this, but it's not possible in flowchart. So that's why what we will do is I will just decompose it. What I will say, Now I will simply call fact of n minus 1 comma out. Okay, I will just remove this one. I will just remove this one and call it like this. So in the call task itself, I will do it like this. So I will do fact of n minus 1 comma out. Okay, so what happens is whatever that comes to this out, whatever that comes to this out will be coming to this, right? And the next step I will do is out is equal to its out. Okay, is equal to out into n. Whatever output that comes will be replaced here, and n anyway we got it, right? So for example, it is 3. We are calling it with 2. So 3, the output of n minus 1 will be replaced here and the output will be given. So I'm just decomposing it. So instead of writing n into fact of n minus 1 comma out, I'm just calling it before. Okay, I'm just calling it before, so that whatever that comes to the output, I am sending it to the other line. So I'm simply doing n into out will be assigned to its out. This is how I am calling it. So I hope you are getting it. Slowly I will explain it. Wait, I'm just trying to decompose it. So first of all, I will call with n minus 1. Because our n is 3 in our case, we simply call itself fact of n minus 1. That means it will be 2 and it will be out. Now remember, because this fact of n minus 1 comma out is called, again it is calling itself and checking whether yes or no, right? So whatever it is calling, because it is calling function to itself, the output will be returned to it. I will explain it on board anyway. Now because we got the output here, next thing that I do is assign it. Assign how much? Like I
Out,
will do
out,
out is equal to
out into n.
n. Okay, so whatever that we got for n minus 1 function, factorial of n minus 1, that will be here, that will be multiplied with n. This answer will be given to out, and this out will be sent to the fact answer in the main. Okay, this is the only output that actually returns to the final main. But here you look into this, you see how I will explain it. I'll just cut this and copy it on the board. Okay. Right. Okay. So now here we need to talk about this one. So what happens is initially I am calling it from the main itself, from the main. In main I have called like fact of n comma answer, fact answer. Okay. Now n is actually 3 comma fact answer. Fact answer will be null. So whatever that receives here is 3 and null. Okay, 3 and null. Now you check. It will come here and check whether n is equal to 1 or not. Because n is not 1, it will go in this direction. Now we come here. So this is the one I'm doing now. You see. So here you come and you will write something like fact of 2, because n is 3 here, n is 3, n minus 1 in the sense, I think, are you able to see my?
2.
So n is 3, n minus 1, 2. So actually when calling this function, this will be 2 comma null, because still we are not getting the output. So it will be 2 comma null. That's what we are sending at present. What is the next step that we are doing is out is equal to out into n. I think if you write like this, out is equal to, we don't know out still, this is still null, right? Into n. So we are not returning it until we get the answer instead of null. Okay, null బదులు ఆన్సర్ వచ్చే వరకు ఇక్కడ రీప్లేస్ చేసి మల్టిప్లై చెయ్యం మనం. Then only you will send the output. Until unless null is replaced, the output will not be sent. Now coming to this position, again you think about this one. You see, now instead of, because we are now focusing on this, because we are focusing on this, imagine that it is calling itself again. Okay, so this time what you are receiving, you are receiving 2 because you are calling itself, and this is null. Okay, so again you will check whether n is equal to 1, n is not equal to 1, n is greater than 1. So again you go this side, come here and write down the statement. Again we will write down. So now we are here with this. Okay, so now fact of what is n minus 1, what is present n? 2, right? So what is 2 minus 1? 1. Until the output is null, right? What is the next statement that you have? Out is equal to,
Out
our
into
still output is null into 2, right? Because n is 2. Okay, for this statement. Fine. And now you focus on this. What is this statement? Fact of 1 comma null. Now what happens here? It will be receiving this one. So 1 will be received because I am calling itself again null. See, until null is replaced, it is not giving the output back to whoever it is calling. Okay, and I will just say it like this one is calling this. Okay, and we will get back to it, and this one is calling the next one. Okay, now here you see n is equal to 1 already. So it will go to s this time. And what is the output? Output is n. So the thing that you do is you are not actually writing these statements. These statements are only possible if it is greater than 1. But because it is equal to 1, the statement that is possible is out is equal to n. So what is our n present? 1, right? So this out will be returned to whom? This out will be returned to this one. So what will happen here? Because you see blue color, it is calling it, so out will be returned to this. So instead of null, it will be replaced with, let us go with green only. It will be replaced with 1. So here also, because we got the output as 1, it will be replaced with 1. So what is 2 into 1? It is 2, right? So out will be given as 2. So out is equal to 2. Because null is replaced with a number and multiplication has been done, now it is eligible for returning to whomever it called. So the never call చేసే ఈ output ఎక్కడికి వెళ్తుంది? Where it will go? Where this output will go?
So the first step.
Yes, to the first, because it is calling it. So it will be replaced with this null. You see, this called this, so output is returned to this. Because this called this, the output will be returned to this. So instead of null, you replace it with the answer 2. And here also, instead of null, you replace with the answer 2. So 2 into 3, 6. So your output will be 6. And to where this output is sent? To whom?
Main function.
It's the main function.
Main function.
We have called it. So here the fact answer, which is there here, will be replaced with 6. And if you are trying to print fact answer, the 6 will be printed. And this is how the recursion actually works. Did you all understood how it works? Yes?
Yes.
Okay. So,
Sir, I have a doubt, sir.
yes.
Sir, it's not a loop, no, so how it keep going to starting point, sir? Like if you take 5, then 4, then 3, 2, 1.
Yes.
How it works?
What happens is
Yeah, no incrementation.
there is nothing equal to loop here. What I simply do is this person is a questioner. He's questioning something. Okay, he asks somebody, what is the capital of India? So this person listens to this. So this person is actually calling this person, right? He is asking what happens to what is the capital of India. This person also don't know about that answer. He keep it blank and ask the other person, hey, what is the capital of India to this? Again, a question is posed. And this is called by this person, right? And the other person, this person also don't know, and he also calls him, hey, what is the capital of India? And finally, this is the knowledgeable person. So what happens is, this is the end point for our recursion. This person knows the answer. He will tell it is Delhi. Okay, it is Delhi. And what this person will give the answer as,
Previous person.
okay, the answer is Delhi. And this person also gives the answer as Delhi. So this is how it actually works actually. Did you understand?
Yes, sir.
So the simple thing is you can do the same thing. If he says what is the factorial of 3, what this person will do, he will keep 3 with it and say what is the factorial of 2. This person, what he will say, he will keep 2 with him and ask what is the factorial of 1. He will say, okay, it is 1. So you will multiply with 2 into 1 and say, it is 2. And what this person will do, will
Three
say
into
2 into 3. And so finally he will say it is 6 to him. Did you all understood how it works?
Yes, sir.
Of course, these are different persons here, but here our function is calling itself. Did you understand? Like a mirror. Okay. So, if you consider this one, the person is asking himself, what is the factorial of 3? So he is thinking. So he divided like, okay, 3 we keep it aside. And what is the factorial of 2? Okay, you got 2. Okay, you keep 2 also aside. What is the factorial of 1? Again, you got 1. Okay, keep 1 also aside. Finally, you got the answer. You multiply 3 into 2 into 1 and you got the answer.
6.
I hope you all understood how recursion works. Right?
Yes.
Okay. Now, we come to our logic and check out. Invalid n. Oh, it's not n. I'm sorry. It should be num.
Num.
Num. Because I'm using num there and using n. Because it doesn't recognize n, right? It only recognizes num. Because it's another world. Like earlier I have explained. Here also num. Num minus 1.
And in that out.
Num. Okay. Now let us check again. Okay. So I think you got the answer here, 6. Okay. So if you can test it once, you can copy this flowchart. If you understood, you can write it down and keep it slow phase and observe how the values are being attained and they are being copied and got the answer. If you understand that, the next task I am giving you is to find out the sum of n numbers. It's also very easy to find out the sum of n numbers. Also, you will simply write it like this. So you will say find out the sum of 5 numbers. So you will say 5 plus 4 plus 3 plus 2 plus 1 plus 0. This is where you stop, or you can also stop at 1. And finally your answer should come. Okay. So first of all, I will open this for you. It's only calling the function and printing the function, nothing else, right? You know already how to do that. And I am just showing this one. Just copy this and test the factorial. Test it with slow speed and observe it how it works. So if you have finished observing it, you can also try for sum of n numbers.
Hello, sir. Hello.
Chepama.
Sir, I'm having one doubt, sir. Can I share my screen, sir?
Yeah, I will stop sharing it. Wait.
Yes. Sir. Hello, sir. Can you see my screen, sir?
Yes, yes.
Like, sir, whenever I put this any number like 5, it's showing fact answer not found, sir.
Because that out also you have given as in there in that C
Alert from
chart.
This
your
one.
is almost full.
Yes.
Okay.
You need to untick input and tick output. Yes. Now you can see that it is belonging to the category of output. Okay.
Yes, sir. Yes, sir. Yes.
Yeah.
Thanks.
So you should be very careful that what should be the category of output and what should be the category of input.
Yes, sir. Thank you, sir. Yeah, sir. And that sum also completed, sir. Sum of n series.
Okay, good. So now I think you can try Fibonacci also, if you can.
Fibonacci.
Fibonacci, I think we have done it with loop, right?
Yes, sir. Loop function.
Yeah, you can try it out with recursion. You can think about that. In the meanwhile, the other people will do the sum. Okay.
Yes, sir.
Sir,
Yeah, tell me.
sir, instead of assigning a value to n, we can also use input function, right?
Yes, yes.
So it can be universal, like whatever value I give, it will execute for that.
Regarding what you are saying, is it in recursion you are saying?
Yes, sir.
Have you done anything different? Can you share the screen if it is different?
Instead of assigning that n to 3, I just took a input function.
Okay.
Uh,
Uh-huh.
Can I share my
Yes,
screen?
yes. You can.
Didn't do anything much. Instead of taking this assigning, I just took enter a value, get n.
Hmm. Okay.
When I run it, printing 10, so it's correct.
Okay.
Like I was having a doubt that in this, instead of taking input, you took assign n is n to 3.
You can take anywhere. You can
Uh,
take anything. Yeah.
that's what
If
I'm
your
having.
choice, you are
Uh,
giving like dynamic one. I have just
mm,
given a flowchart where you are writing like for giving you demo. I said n is equal to 3. But you
yes,
can
sir.
use this get. Yes.
So I was having doubt. Can we do it in universal way? Like whatever value I give, will it
Yes,
execute on?
you can do it.
Okay, okay, okay. Thank you.
Yeah. So try out that sum of n numbers and Fibonacci series,
Mm,
and I think maybe if time left today for you, you can also try doing all of you. I'm telling to all of you. Uh, until now, you have done different flowcharts, right? You now convert it into functions. So there will be one main flowchart from where you call a function, and in that function you will have this functionality that you have written. For example, I think you have already done Fibonacci series. Now do it as a function. For example, you say what is the Fibonacci of 5 months.
mm,
So what will happen is that it will go to that Fibonacci series function and do all the logic that you have already written,
mm.
and put the output value in the output. So that will be received by main, and it will be printing it. So convert all the programs to function now. The next task is that. So today you at max do all these things. Tomorrow in the lab we will check out randomly. I will ask people to share their screen of what they have done. And today's task is this. You need to convert all the programs you have done as a simple flowchart into functions. And along with that, you need to do these recursive functions. Like one is factorial, the other one is sum of n numbers. Fibonacci, if you are interested, you can do it. Otherwise, tomorrow we can discuss the solution.
So what is today's task, sir, actually?
Today's task is to convert all the programs that you have done until now as simple flowcharts, right? Convert them into functions and get the answers. Okay.
Okay.
Then we can also do the sum of squares using recurring function.
Yes, you can do it.
Okay.
From starting, no, sir, everything?
Yeah, from starting onwards, I think we have done very few programs. Of course, you can convert all of them into functions. Whatever program you have done. Like
The
I said,
recurring functions, no, sir?
not recurring functions. It's like normal functions. Like I said, like add. So
Mm,
initially you have done one flowchart like a plus b directly in that main flow,
mm,
right? Now you
Mm-hmm.
convert it into functions like add function. So you have done factorial program. Now convert it into factorial function like that.
we have to create a function for that, and whenever we call that function, it should do that process.
Yes, yes, that's all.
Okay, sir.
So all the logic you have done in the main world. Now I'm asking you to use main world only for calling the function, and all the logic should be in the function itself. It is very simple. Just create a function and put input and output and copy all the logic that you have already done in the flowcharts previously. I'm not asking you to do anything new logic. The old logic, you convert it into function. That's all. So you should be knowing how to call and how to know what is called function. That's all.